Lesson 10-8, combining functions. When we combine functions, we are either going to be adding the functions together, subtracting the functions, multiplying, or dividing the functions. Today we want to just look at when you're adding, subtracting, and multiplying functions. Now there are a couple ways of doing these. When you're adding and subtracting, if they tell you what x is, in this case they're telling you what x is here, so they're saying x is -3. If you have two functions, like f of x and g of x, you could substitute the value that they give you for x into each of these functions. Like for f of -3 and then g of -3. Solve each function and get two answers, 19 and 16, and then you just add your two answers together and you get 35. The other method would be to add the functions first, then substitute the -3 in. So they're just combining x squared minus 2x plus 4 and -5x plus 1, which gives them an equation of x squared minus 7x plus 5. From that point, then all they're doing is substituting -3 in there, and they get 35 as their final answer, which is the same as if you did it the first method. Let's take a look at some examples. We're adding f and g of x together. We do not know what x is, so we're just going to keep x in there. So for what I would do is I would just line them up. So I would just say 3x plus 1 underneath here. And if I add straight down, I'd have now 6x squared plus 4x minus 1. And that would be our new function. So I'm just adding those functions together. If I add f and g of x in the second example here, I'm going to bring this g of x, 10x minus 8, and put that underneath here. So I'm adding 10x minus 8 here, add straight down, and I get 3x squared plus 9x minus 3. And that would be our function. Next, if we're subtracting the functions, here you're going to have to distribute a -1 to the second function. So if I have -x squared plus 4x minus 5, I'm supposed to be subtracting x minus 7 to that. So if I'm subtracting, I'm distributing a -1. So I have -x squared plus 4x minus x minus 5 plus 7, which will give me an answer of -x squared. 4x minus 1x is a positive 3x, and -5 plus 7 is a positive 2. Second one, g minus f. So if I have x minus 7, and I'm subtracting a -x squared plus 4x minus 5, I now have x minus 7, and I'm subtracting a -1x squared, which really makes that a positive x squared. I'm subtracting a 4x, so that's a minus 4x, and I'm subtracting a -5, which really means I'm adding 5. If I add straight down, I'm left with x squared minus 3x minus 2. So again, we're just combining like terms here. Next, I'm subtracting f of x and g of x. So I have 4x squared plus 11, and I'm subtracting 9x, and I'm subtracting a -11, which really means my answer is going to be 4x squared minus 9x, 11 minus a -11, which means I'm adding 11 to be 22. Next, I'm adding f and g. So if I have 2x minus 1, I'm adding a -3x squared plus 2x minus 8 to give us an answer of -3x squared plus 4x minus 9. And the last one, I'm subtracting h and g. So h is 4x. So I don't have any x squares. 4x minus 5, and I'm subtracting negative 3x squared plus 2x minus 8. So if I'm subtracting that, that gives me a positive 3x squared, a minus 2x, and a positive 8. Add straight down and I get 3x squared plus 2x plus 3. Looking at multiplying functions, when you multiply functions, you're just really using the distributive property. And again, with this one, they're telling us what x is. They're saying x is 2. So you could find f of 2 and then g of 2 and then multiply your answers. Or you could just solve first and then plug in the q in for x. Either way, you'll still get the same answer of 72. For example, f of x equaling x squared plus 2x minus 7, and g of x equaling 3x minus 10. They want to multiply those. So I have x squared plus 2x minus 7 times 3x minus 10 distributes. So I have 3x cubed minus 30x squared. 2x times 2x is a positive 6x squared minus 20x. And I have negative 21x plus 70. And I get a final answer of 3x cubed minus 24x squared minus 41x plus 70. And our last one, we have 5x squared minus x plus 2 multiplied by negative x plus 1. I distribute, I now have negative 5x cubed plus 5x squared plus 1x squared minus x minus 2x plus 2. And we get a final answer of negative 5x cubed plus 6x squared minus 3x plus 2. Another one with multiplication. Going to multiply these together. So distributes gives me a negative 12x cubed plus 8x squared plus 30x squared minus 20x minus 18x plus 12. Add together, we get negative 12x cubed plus 38x squared minus 38x plus 12. Moving on to example 4, word problem format. So there's 4 steps in these. You have to come up with our functions first and then use the functions to simplify. It says a sandwich shop charges $7 for a large sub and sells an average of 260 large subs per day. The shop predicts that they will sell 20 fewer subs for every 25-cent increase in the price. Let x represent 25-cent price increase. Write a function p of x to represent the price of a large sub. So p of x equaling, they start off with $7, and if they're going to increase the price, that is 0.25 per increase. T of x is going to represent the total number of subs sold. So T of x, if they start selling at 360 at $7, they sell 20 fewer less, so that's 20 per increase. So that would be 360 minus 20x. Part C, now we're going to write R of x for revenue. And that's going to be finding the maximum revenue of sales for the large subs. So you're going to just take your P of x times your T of x. So if P of x was 7 plus 0.25x and T of x was 360 minus 20x. We would just FOIL this. So 360 times 7 gives us 2520. And then we have 7 times negative 20x. That's a negative 140x. And 360 times 0.25x is a positive 90x. So if I combine those, that gives me a negative 50x. And then 0.25x times negative 20x is a negative 5x squared. This is what our r of x is going to equal. If the sandwich shop charges $8.50 for a sub, that means that's a difference of $8.50 minus $7 is $1.50. If they're increasing it, if they're increasing it by 0.25, if I divide 1.5 by 0.25, I end up with 6. Well, x is going to be 6. And this is going to tell us what the total revenue would be. So negative 5 times 36 minus 50 times 6 plus 2520 gives us an answer of $2,040. Next, the tennis team is selling bags of mulch for a fundraiser. Last year they charged $4 per bag. They sold 100 bags. They predict that they will sell 40 fewer bags this year for every 25 cents more that they charge per bag. So T of x, right? The function T of x represents the price of a bag of mulch, where x represents the number of price increases. So they normally do it $4 plus 0.25 per increase. M of x is going to represent the number of bags of mulch sold. So M of x, they sell 600, but they sell 40 fewer, so minus 40 per increase. Once we have our two functions, now we can do part C and D. Part C is find the revenue. So again, revenue of x will be your T of x times your M of x. So that gives us 4 plus 0.25x times 600 minus 40x. So if I distribute, that's your 2400 minus 10x. And put the minus 10x here. And then 600 times 0.25 gives us 150. So that's positive 150x. 4 times negative 40x would give us a negative 160x, which a negative 160x plus 150x is a negative 10x. And then we have 0.25x times 40, which would give us a negative 10x squared. So this is our function. And it says the tennis team charges $5. So 5 minus 4 from what they originally was 1. And they're increasing it by 25 cents. So if I divide that by 0.25, that gives me 4 price increases. So if I have negative 10 times 4 squared minus 10 times 4 plus 2400, that would give us a revenue of negative 10 times 16 minus 10 times 4 plus 2400 gives us a total of $2,200. Next, the restaurant is trying out a new dish on their menu. Last month, when they charged $25 for the dish, they sold 800 dishes. The restaurant predicts that for each 50 cents that they drop price, they will sell 90 more dishes per month. Write a function for the monthly revenue from the dish if the restaurant drops the price X times. Find the monthly revenue for the price of $22. So with the money, it's $25. minus 0.5x, which means they're dropping it 50 cents each time. That's one function. The other function is dealing with the number of dishes. So if they, at $25, it's 800. When they drop it, they increase it by 90 more per price decrease. So if I do 25 times 800, that gives us 20,000. 25 times 90 gives us 2250. That's 2250x. Negative 0.5 times 800 is a negative 400x. And then negative 0.5 times 90 would give us negative 45x squared. So 2250 minus 400 would give us a positive 1850x. So our correct equation would be B. And how did they get 29,480? If the original was $25 and now they dropped it to $22, that gives us $3. But they were decreasing it by 50 cents each time. So if I divide that by 0.5, 3 divided by 0.5 would give us 6. So there was 6 price increases. So if I put 6 in for X, negative 45 times 36 plus 1850 times 6 plus 20,000, you would get 29,480. Last part is dividing functions. So functions can also be divided, and because division by 0 is undefined when dividing two functions, there may be restrictions on the domain of the quotient. It means whatever your variable in the denominator is equal to. Restricting the domain of a quotient ensures that the new function is defined for all values of its domain. So for two functions, f of x and g of x, the quotient h of x can be expressed as f of x divided by g of x, where g of x cannot be equal to 0. One example, given f of x, 2x squared minus x minus 28, g of x is 2x plus 4, determine the domain. So if f of x is 2x squared minus 10x minus 28, g of x is 2x plus 4. We just need to determine the domain. So the domain is the denominator. This cannot equal 0. So to solve for x, I would subtract 4 on both sides. 2x cannot equal negative 4. Divide by 2. X cannot equal negative 2. So when x is negative 2, then it would be undefined. So we can write the domain couple ways. We could do x such that x is less than or equal, or the less than negative 2, but greater than and greater than negative 2. That's one way of writing it. Let me write that again. So we could say x is less than negative 2 or x is greater than negative 2. Or you could also write it as x such that x cannot equal negative 2. So those are your two ways of writing that. Then our last one here, we need to divide f of x and g of x and determine the domain. So I have 5x squared minus 6x plus 1. And I'm dividing this by 4x minus 14. So the denominator cannot equal 0. So I have 4x minus 14 cannot equal 0. Add 14 to both sides. Now I have 4x cannot equal positive 14. Divide by 4. Divide everything by 2 halves. I would have the domain is x cannot equal 7/2. Or you could say that it would cannot equal 3.5. Another way of writing this would be x such that x is less than 7/2 or x is greater than 7/2. So that is our lesson on combining functions.